So we talked about subsets. Now we're going to talk about proper subsets. That's a very specific type of subset. A subset B is called a proper subset of A if and only if every element of B is an element of A, but B is not equal to A. And the way we denote it is just with the little C shape. So it's like before when we used this for subset, but that meant less than or equal to. What they're doing here is they're taking away the equal to part. So it strictly has to be less elements in B than you have in A. So the cardinal number of B, the number of elements in B, has to be less than the number of elements in A. Strictly less than. It can't be equal. The null set, which has no elements, remember your null set, the empty set, it just literally is empty brackets, that's a proper subset of every set because the null set doesn't have any elements. So 0 is always going to be less than however many elements your set has. Another way to write it is like this. This is what's called a Venn diagram. We're coming up on these here pretty soon. We're going to talk more about Venn diagrams, but we have set A, and then inside of it is set B, and you can see that set B has less elements than A because the circle is smaller. That's just the way they denote it. So let's just try a couple examples here. If this is set A, it contains the elements 0, 1, 2, 3, 4, and 5. Let's just see if these following sets are proper subsets, meaning they have to have less elements. So B contains 0, 1, and 2. Are 0, 1, and 2 included inside of A? Yes, they are. And B has less elements than A, so B is a proper subset of A. Set C contains 1, 3, and 5. Those are also included in A. C has less elements than A, so it's a proper subset. D contains 1, 2, 3, and 6. Well, that 6 is messing it up because 6 is not inside of A. So D is actually not even a regular subset of A, but it's also not a proper subset of A. E contains 0, 1, 2, 3, 4, and 5. So does A. So E is a subset, but because it has the same number of elements, it's not proper. It has to have less elements, and that one does not. F is the empty set, so it has 0 elements. Of course, that's going to be a proper subset. 0 is less than however many elements your set has. In this case, A has 6 elements, so 0 is less than 6. Let's try a couple more here. Let's suppose we're looking at set A, which contains A, B, C, and D. We're going to fill in each blank with the appropriate symbol, either element or not an element. Remember, this means element. This means subset, and then this one means proper subset. And we're asking, is it an element or not? Is it a subset or not? Is it a proper subset or not? So do you see how we're comparing most of these to set A over here on the right? One of them I'm comparing to the null set. But do you see how sometimes it's just a letter listed and sometimes it's got curly brackets? That's a really big giveaway. If they put something in curly brackets, they're talking about either a subset or a proper subset. But if it's just like a single letter that's out there by itself, they're talking, is it an element? So you can tell if it's the subset symbols or not based on if curly brackets are used. So these first 3 are just elements that are listed, no brackets. So is little a an element of big A? Yes, it is. So we would say element. Is E, little e, an element of A? No, it's not in there. Is E an element of the null set? Well, nothing's an element of the null set. The null set is empty. So this would be, can't be an element of the null set. For the rest of these, we're going to use subset or proper subset, whichever one is the most specific. So the null set versus A, is it a subset or a proper subset? Well, it's both. Technically, it's proper, but it's also just a regular subset. But I would say proper is the most specific that we could say here. It is a proper subset. How about AB? Is that a subset? Are A and B included inside A? Yes, they are. And AB has less elements, so I would say this is a proper subset. It's also a regular subset, but more specifically, it's a proper subset. How about A, B, C, D, E? versus ABCD. Well, that E is kind of screwing it up, so that's not a subset. So it's also not a proper subset. If it's not a subset to begin with, how could it be a proper subset? So it's neither one. How about CB? Is CB included in A? Yes, it absolutely is. And CB has less elements, so that's a proper subset. It's also a regular subset. And then the last one, ABCD, well, that's exactly the same as set A. So those are actually equal. So it is a subset. Is it a proper subset? No. So it's not a proper subset, but it is a regular subset because of that equal, because this set is equal to A. So that's why it gets to be a subset. It just cannot be a proper subset.